Chaturvedi.
And I am Deepak Kumar.
Our project is about IoT-enabled pollution meter, and we are using Node MCU, DST11 and MQ135. DST11 is a temperature and humidity sensor, and MQ135 is air quality measuring sensor. So basically, our project has two objectives. First one is we are sending the data from the Node MCU to the Blink server, where the Blink server will represent the data in our mobile application. And our second objective is we are sending the data from the Node MCU to the central server, where our Linux machine is acting as a central server. So basically, the central server will act as a data storage purpose, and the data will be stored in a CSV file. And later on, we will implement KNN machine learning algorithm, which will classify the data into as rainy and sunny, and it will also tell us whether, about the air quality, whether it is good or bad. Now coming to the connections.
So here is the connection. Here we are powering Node MCU through the power bank, and DST11 output pin is connected to the D1 pin of Node MCU, and its ground connected to the ground of Node MCU, and VCC connected to the VCC of Node MCU. And coming to the MQ135 sensor, here its output pin is connected to the A0 pin of Node MCU, and its ground to the ground of Node MCU, and its VCC to the VCC of Node MCU. Here DST11 is sensing temperature and humidity and sending the data in digital format to Node MCU, and MQ135 sensing air quality and sending the data in analog format to Node MCU.
Now we'll show the demo.
So in the application you can see it showing humidity, temperature and air quality, and also plotting the live graph, as you can see here. Okay. So here is the live graph. Now coming to the central server, as you can see here, it's showing humidity, temperature. We are storing the data in CSV file. Here is the CSV file. As you can see here, and it's storing with timestamp. Okay. Now coming to the server, you can see here it's showing the data, humidity, temperature, air quality, and its classes of the weather and air quality, whether it's good or bad. So for this we need training data. So for the training data, here we have given the training data to the program in CSV file. You can see here. So now this is the server, it is running and it's showing the data.
Hello everyone, we are here to present our class project, which is a Smart Bike Toolkit. I am Rajkumar, MTech first year. He is my teammate Aman Misra, MTech first year Computer Science. Now, some basic information about our project is, this is basically a gadget which help in bike safety, security, and also help to detect the bike accident. The basic component used in our project is Node MCU 1.0. This is Node MCU 1.0, and accelerometer sensor, gyroscope sensor, GPS sensor, and matrix keypad. This is a one sensor, MPU 6050, which contains three type of sensor: accelerometer sensor, gyroscope, and temperature sensor. We are using only two sensor, accelerometer sensor and gyro sensor of this sensor. Now, for bike safety purpose and bike safety and security purpose, we using accelerometer sensor and password protection. Now, for bike accident, for checking the bike accident, we are using accelerometer sensor, gyroscope, and sending the location of the accident happen, we are using GPS of our mobile. Now, for communication purpose, we are using MQTT, or for connectivity, we are using Wi-Fi. We are using decision tree algorithm of machine learning for training around 500 data set.
Now I will explain the working principle. Suppose the bike owner has kept the bike here and gone somewhere. Suppose someone will try to steal the bike, then there will be some change in motion. And also if the bike has fallen away, then also there will be some change in motion. The motion sensor will detect it, the accelerometer sensor will detect it, and it will publish a MQTT message. And the owner has a Android mobile and he has a mobile client, MQTT client. He has subscribed to that topic, so he will get the notification. Next thing is, whenever someone will try to steal the bike using unlocking the password, first of all the owner has to unlock the bike giving the right password. If someone will try to unlock the bike using wrong password, if he tries wrong password 3 times, then also the theft message will go to the owner's mobile. When the authorized user will come, he will give the right password and he will ride the bike. Suppose he meets a bike accident, then what will happen? The accelerometer sensor and gyroscope sensor both will capture the data, and we are using data analytics for that. I will explain that. And they will publish the message of the accident, and the message will be sent to the mobile of the owner's relatives. Now I will say about data analytics. Initially, what we did is we trained the bike about how the accident happens. Means we move the bike like that, and we trained it how the accident happens. We collected about 500 data sets, and then we applied descent tree algorithm to make the model. Then we fed the model into the node MCU. Okay, this is how our project is. So first of all, if someone tries to steal the bike, then he will move the bike.
First.
It got that. So it will send the theft message. If the bike will fall away
Without unlocking the password.
without unlocking the password, if the bike falls away, then also it will send the message to mobile. I got a notification. Next thing is we got a
Notification. Separate.
screenshot. We'll post the screenshot.
Someone try to.
If someone gives the wrong password, unlock it. Can't run. Pause. If someone will type wrong password for 3 times, then also it will send a message to the owner. Now restart it. Now authorized user types the correct password. Now he is riding the bike. When he will meet the accident, it will send the message. We will show a demo. You can see it will send the message. Now I will show. This is the message I got when I got the safety alert. Means either the bike is fallen or someone tries to steal it. Next thing is, this is the message I got when someone gives the wrong password. Then it sends the thief message. This is the message I got when the accident happened, and the GPS sensor sends the latitude and longitude to the owner's relatives.
Thank you.
Hello everyone, my name is Gaurav Gupta and he is Shagun Tudu. We are from Computer Science and Engineering Department, IIT Kharagpur. Today we are going to present you IoT project. The topic of our project is road accident detection using heartbeat sensor. So basically, whenever a person goes through a bad road accident, then its heart pulse gradually starts slowing down. So whenever its heart pulse will come below to a certain threshold, then we will send its location and his heartbeat data to his relatives. So basically, through this we can actually save his life by informing his relative as soon as possible. So now we are going to show you what component we are going to use in our project.
Coming to the components parts, in the software part we are using Arduino for coding, and we are using MQTT Dash and Blink app, and other than software we are using hardware. The main components of the hardware are Node MCU and there are 2 sensors. One sensor is GPS module and the one is heartbeat sensor. This is the heartbeat sensor and this is the GPS module.
Now we are going to show you how we are going to connect it. So we have the heartbeat sensor. So we have connected it through one wire on the ground node and other in the voltage, and one is the analog node. And now we have the GPS module. We will show you the connection in the PDF we have provided. So basically we are powering through our power bank, and to basically transfer and for other purposes we are using MQTT softwares and Blink app. Now we are going to show you how the workflow, how this actually works.
Coming to the workflow, first of all, from this device we are sending the GPS location to the user's phone, directly to the phone, using Blink app. In the Blink app we are sending that, and the sensor means in the heartbeat sensor heartbeat data which we are sending from here. It is directly sending to the MQTT server in the cloud, and after that the MQTT server it is coming to the user's phone in MQTT dash.
Now we are going to show you how it actually working. Here, after touching the sensor, we are getting the reading here of the heartbeat through the MQTT broker on our mobile. So you can see the heartbeat pulse is rating 73 right now, and now we will send the location of the person on the Blink app. So here we have the location of the person showing on our Blink app. We have set the threshold less than 75. You can actually set it to even below than that, so that whenever person go through an accident, its heartbeat pulse is basically below from the normal. So through this we can actually detect where the person is right now and what is its heartbeat. So as soon as we get this information, we will be able to rescue him. Thank you.
Hello everyone, my name is Vishal Kumar from Computer Science and Engineering Department. My demo project is fire alarm system, which are used to detect the fire and send and alert the message to owner and the nearest fire station. So here we use two nodes, which are used. One are used for the two nodes which are placed in different places, which are used to detect the fire. In first node, here is first node, which contain the node MC, which are used for the processing of data. In second node we use the Arduino, and here between two nodes we can communicate through a Zigbee, and from Zigbee this node send the data through this node through Zigbee device, and this node send through Wi-Fi to a broker, MQTT broker, which I installed in my local server. Here is a nearest fire station which can subscribe the topics through, which are used in my MQTT. Here is a fire stations which are subscribed the topic project /IIT/KGP/IoT. So this it automatically get a message which can monitor the room conditions. Here is room condition is temperature, humidity, and what is condition is there is smoke or not. So this say that there is no fire, so smoke value is what, and is flame sensor. Here we use two sensors, which one is flame sensor and another is smoke sensor, which are used for detecting flame sensor used for detecting the fire, and smoke sensor for use for false negative. And this alert also be sent to a owner through MQTT client. So owner also subscribe the topic of MQTT. They also get a message that is sent by the broker, which are installed and locally. In this mobile, they also get a no fire and current situation of the room where the node are installed. So now we are put a fire. Now here is the flame sensor which are detect for the fire. Now we are we are test that if there is it is a flame which is detected by the flame sensor, and automatically they budget the sound. So nearby people also get a alert and also flee from the that place. And here also get a message there is fire. Here we have burn flame, then automatically detect the fire, then also buzzer sounded, and also get a alert message through a fire alarm system. Here is a fire breakout and what is the condition of the room, and what is temperature. Here this show that fire broke out and what is the flame value and temperature value of that room, and also get a message in the mobile, that is he also get a message that is fire broke out, what is the condition.
Keep it for some time.
Here we show the fire broke out, which alert the owner about the condition of room, and what is the condition, if there is also there is any smoke. So it is smoke sensor show the value of the room condition. Thank you.
Hi, I am Akash. I am MTech first year student from Department of Computer Science and Engineering, IIT Kharagpur. So the demo that I am going to show is about RFID-based attendance system. So basically we are using RFID technology, that is very short range communication technology, and then building attendance system out of it. So already RFID systems are widely used in all the companies and for authorization as well as attendance purposes. Various institutes also use these for student authorization and attendance. So the hardware components involved are, this is Raspberry Pi, that is model 3B plus, and this right here is RFID RC522 scanner, that is basically a RFID scanner. So these are RFID tags. All these tags, these are two different types of tags, but although the thing is same. So these all have a unique ID associated with them. So this scanner, whenever we will place these in the close proximity of this scanner, the data, their unique IDs will be read, and accordingly we can process it by writing the code in whichever way we want. The way this is going to work is the students will be given these RFIDs. So each RFID, their unique ID will be associated to one student, and using this they will mark attendance, and this device will be placed in the class, and whenever they will place this card like this, so their UIDs will be read and their attendance will be marked. So how we are approaching on this is, we are setting a timer for that's on our convenience, but we are setting it for 10 minutes. So in the middle of the class or in the beginning of the class basically, a professor will turn on the system, and then students can easily mark their attendance, and now their attendance will be stored in database that is set up in this Raspberry Pi, and each attendance will separately be notified to professor on using MQTT protocol, and also whenever all the students have marked attendance or the timer that we have set is expired, the complete list of students, those who are present and those who are absent, will be notified, will be published to the published over MQTT, and professor can receive it. So also there are some other things like some sort of data analytics is performed, which will also be sent to a professor, so that they can judge students based on their attendance, like which student is attending classes more frequently and so on. Okay, so now this system is running. I have run the code. Now whenever I scan it, there will be a message, and that will happen for every ID. And if some unauthorized ID is placed, then there will be no message, and even our code will not accept it, and we will simply reject that entry. Thank you.